Howdy! You're going to be doing a lab this week entitled Evaluating Climate Data. I understand that the word data, database can be very intimidating, and I want to encourage you to take a step back and realize it's really not that intimidating. And I'm going to walk you through basically how you're going to manipulate some data that's in an existing database that's from the National Oceanic Atmospheric Administration's website for National Centers on Environmental Information. NOAA basically manages all of the climate data for most of the federal government. Not all, but most. And so when we think about climate, we really need to be looking in long-term aspects from a human reference, not necessarily from a geologic lens. Truly, from a geologic perspective, we would need hundreds of thousands of years of data, if not millions of years of data. And the only place that we can truly get that kind of information is in ice core samples. So we're not talking about that. We're talking about atmospheric information that's been received from whether it be weather balloons, other weather types of stations, some form of monitoring, and it's been put into the central clearinghouse of information. And all you're going to do is research how these different databases work and do a couple of simulations or queries, and you're going to kind of put that information together to tell a story. So that's the big picture. We can do it at the global level. We can do it at the national level. If we take the United States, we can break it into segments for regions. Then we can actually look at it by individual state. Then you can go to county and, believe it or not, even down to the city level. So we're going to do a little bit of a hodgepodge of not all, but most of those items. And I'm going to help you be able to figure out what parameters you're going to set, because that's the scary part for most people is I don't know how to set the database up. Well, if you follow my instructions in the lab, all you have to do is select basically the same items with one variable difference, or if I'm asking you to go from national to state or from state to a city, then you would change that aspect. So this is the NOAA's website for the National Centers on Environmental Information. And let's say the website doesn't come up readily available with what I put in the lab folder. You can do a search for this and find it yourself. This is a widely used website for people who are in agriculture, city planning, state planning, policymakers, because it encapsulates lots of information for temperature, precipitation, droughts, all of that. And you can look at snow and ice. You can look at temperature changes, mean global temperature over a year, maybe even just a month or a week. You can even look at it for decades. In our case, we're going to spend a lot of time looking at it for the last 50 years. And the reason I want you to look for the last 50 years on most, but not all of these, is because 50 years gives us a human reference of a long-term data collection, because basically that's about the time we started collecting this information extensively for use and modeling like we're doing right here. So I am at the same time going to pull up the lab form that I have in your lab folder so I can kind of follow along and tell you what we're doing. And the very first place you're going to go is this website. And then I'm going to ask that you come into the climate monitoring. So if you can't find it, just do a search here for climate monitoring. You can see on the blue side right here, it's the very first one. So I'll select that. Then I'm going to have you take a look at information for national and global. So we're going to start with national, okay? And you can see there's a 1 month, 3 month, 6 month, 12 month. So when you come into your first database section, I ask you to do a couple of things. I ask you to set this parameter right here for the contiguous United States, and then I ask for an average temperature, just what this setting is. And when you get there, you'll notice that when you hit go, if I did 3 months, for example, you can see a chart comes up down here. This is important because graphical analysis actually help us interpret data points. You can see in this realm right here that there's a degrees in Celsius. Make sure it's in Celsius and not Fahrenheit or vice versa, because that matters. And when you're talking about data, and then it gives you some just simple data points. So you will do a query using that. And then the next one I'm going to have you do, let's see, is one that involves answering these questions about the rank, the warmest sense, the coolest sense, and there'll be a chart for you to fill out. Then we're going to shift gears a bit, and we're going to do it, and instead of it being just the contiguous United States, we're going to come down and do one in Texas. And then you would change that, and it will shift. Just hit return, Texas, and then it will actually load itself up. And I want to point out that we can start to do different types of things. I can do a climate at a glance, and this becomes really powerful. You'll spend a lot of time in your lab doing this. And notice the same global, national, regional, statewide, divisional, county, and city. And then these next items are very important. We'll spend most of it in our time series, because time series is looking at a period of time. And so what you would do, and I'll just give you an example, not necessarily one that you'll be doing per se, but if you follow the directions, you'll be able to make it happen. Let's say we wanted to look at average temperature. I wanted to look at it for 60 months. I wanted my month that I was looking at, let's just say I wanted it to be May. And I want to start looking at 1900 and up until modern time, 2021. Then there's some options over here, and you can see, okay, well, she only has it set up to go to the end of 2000, so I need to bring that up to 2021. We're going to look at it per decade. That's very visual when it makes this graph right here. You can see what happens when you check this box right here, but it adds another line. I don't think you need it right now. And then you hit plot. And then you can begin to see, here's your mean temperature line in Fahrenheit. Remember, this is your Celsius over here. And these are your decades down here on the x-axis. So you see Fahrenheit on the left y-axis, Celsius on the y-axis. And then you can see rankings. These rankings mean something. So while a rank of 1 you might automatically think is bad, I need you to check this out and see if 1 means it's the warmest, 1 means it's the coolest. And if you don't know what these things mean, these dates, just click on it and it'll give you May 2015 to May or April 2020, which was a 60-month period of time. So what does all of this information have to do with your lab? As we get through this process, I'm going to have you do national, then I'm going to have you go to the state, and I'll have you look at some places in Alaska. So when you get to Alaska, you would change from Alabama to Alaska. You would change your parameters here, and then you would plot, assuming that I have the right plotting information, which I don't intentionally at the moment, just to kind of show you how I can generate a data. Well, nothing happened, so I guess we need to look at a little bit more data. Since Alaska doesn't have as much information, let's come in and let's do it from 1970 to 2020. And we're going to start again at 1970, and because that's when a lot of our weather data and information began to become a reality. And again, start year, we're going to get 1970. And so we're going to keep everything consistent, make this 2020 or whatever time period I've asked you to do, and then hit plot. And then you should get, and there it is, there's a plot. So what does this graph really mean? So I'm not going to interpret it all for you, but I'm going to say, let's start way back here at 1970, and let's look at the degrees Celsius. And what you're looking to see is, have things changed over time by decade? And most assuredly they have. So if this is your mean temperature across that entire 50-year time period, that black line, I want you to notice that there's been a gradual increase over time. And then by how many degrees matters, because there comes a point where the Arctic area is so ultra sensitive to climate change that when we hit this temperature threshold, and there really is a threshold, it's enough to start really melting our ice packs, which has ramifications for sea level rise, which in turn has ramifications for where people live along coastal areas. Since a large percentage of most populations around the world that are coastal areas have their populations in the coastal regions, that puts a huge demand on space for living. It also means that people have to move further inland, which may utilize groundwater resources, certainly the case in the United States. For the Ogallala Aquifer, which is what is irrigated for most of our crops throughout the Midwest. That also places stress on how do you deal with water, wastewater, air quality, just the basic things that people need to live. Let's take apart the fact that you could start flooding out people's homes, their businesses, or on the flip side, you have a really big global cooling and sea level drops instead of rises. What would that do? How does that impact people's value of property that had coastal property, premium, real estate values? These are the things I'm wanting you to think about. While we think about the environment simply from a scientific lens, it certainly corresponds to economics. And so at the end of this process, as you're going through these various different modeling scenarios I gave you, and then even coming down and doing a city, and let me demonstrate a city for you, I want you to compare what the cities are. So I'm going to ask you to do a few places in Alaska. Anchorage is one of them, Fairbanks is one of them, and then Juneau is one of them. And each time you would hit plot. They may look very similar, but they're not. Each one is very different in their location, even where they are geographically speaking. So Juneau is actually the capital of Alaska. And if you've been there, you know it's kind of like hard to get to, either by boat or plane. It is not one that you readily can drive to. So it's a stop on the Inner Passage on cruises. And it's very wet, and it sits right at the base of Mendenhall Glacier, ice glacier field, where a bunch of glaciers feed in together. And I'm wanting you to take a look at all of these places because I want you to kind of get a feel for if you were to move, let's say you were to decide to move and take a job in New York City. What does the climate look like? How has it changed? Are there some things you might want to consider? Let's say you decide to move to the Midwest. Maybe you want to become in agriculture. You want to open up a large ranch or farm, and you need to start thinking about what that looks like. You should probably take a peek at this information before you start moving to locations to see how these patterns have changed. That's how databases are used. And if you ever get into an elected official capacity or a city planner capacity, you have to start thinking about zoning, where it's safe to put people, businesses, what that looks like for your economics. And that's how, when the environment and science come together, that's how the bridge is gapped, is by using databases like this. So again, when you start this lab, you're going to come to NOAA's main webpage, and then you're going to type in National Centers for Environmental Information, and I do have the website in your folder, and you're going to follow my prompts. So let me bring the lab form up. This is subject to change if I make amendments, but basically I have guidelines that say, all right, this is what you need to do and what you need to select at each step of the way. And then where you see the word answer, I'm asking you to type your answer here. And yes, I want it in red font. And you may ask why, because it visually helps me find your answers. I do have a couple of learning disabilities, so seeing it very visually helps me find that. I am also requiring that you do not remove any of my instructions, any of my screenshots or illustrations. I need those when I'm grading to know what I'm asking for you to do. So students who turn just 1 through 20 and put answers there, I'm not going to be able to grade that. You need to include the whole lab form. And all you would do is do a save as. Simply come here, do a save as. Save it to wherever you would remember. I would put it on my desktop, and then I would change the name from new to your name, whatever your name is. So if that was me, it would be this, and I would save it that way. And then that's what I would upload to the assignment tool when I'm complete. This is not a hard lab. It's going to take you about a couple of hours to do. And remember, if you met with me every week in person, we would be having 3 hours of lab. So you really won't be spending that much time. A lot of it is just learning to work the different parameters and how to set these things. Like if I wanted to look at maximum temperature, change my scale to a month, which month I'm looking at, my start year, all of those kinds of things, and being able to work through these types of scenarios right here. You will be spending most of your time with the SIME series, but I would encourage you to maybe look ahead and see how this looks with the different types of data that you can produce and different types of maps that you can produce, the state of the climate. Start looking through all of these really cool things that are available through this website. Thanks for your time, and folks, if you ask me questions that are clearly answered in this video or in the instructions, I'm going to have to refer back to both of these for you, because this is not a hard step. It's just a matter of following directions. Thanks so much for your time. Bye.